All right, let's talk about this CSET tiling problem. Um, so, as you read in the homework, in the chapter 1 homework tonight, there was there are multiple ways to solve a problem, of course, and it's good to talk about all the different ways that you could solve a problem. For this particular problem, I think I'm just going to give you one solution. But there are other ways that you could do the problem. So let me just mention, kind of just off the top of my head, one way that you could solve the problem that I'm not going to show you would be you could draw this figure to scale, right? And actually, this is something that students try to do sometimes, but they kind of do it wrong. So a lot of times what I've seen students do when they're trying to work on this problem is they will just use this page and they'll start to draw tiles, and they'll try to draw them the same size as the ones that are already on the page, and then count up how many tiles there are and stuff. And now the problem with that is the figure that you're given here is not necessarily to scale. And in fact, I think if you measure these and draw them perfectly the same size, I don't think that they fill up. I don't think that they quite fill up the space perfectly. In other words, I think these tiles are not the right size to use. But what you could do is you could draw a 42 inch by 72 inch rectangle. It wouldn't actually have to be 42 inches by 72 inches. That would be huge. That would be, 6 feet by, whatever, like almost 4 feet. So obviously you wouldn't do that, but you could draw it to scale. So instead of 42 inches, maybe you do maybe you say each set of 6 inches is worth 1 inch or something, and then instead of 42 inches you would draw a 7-inch rectangle or whatever, right? That side would be 7 inches. Anyway, but the point is you could draw it to scale, and then you could just try to guess and check, right? So you could try squares of various sizes and just guess a size and see if it happens to fill in the rectangle evenly. That probably, like I said, that's not the best way to go about this problem, though. And so that's not the way that I'm going to show you how you might do it. But here's what I will do. So first of all, let's really get a handle on what this problem is asking. So it says, an artist is planning to construct a rectangular wall design from square tiles. So first off, the tiles have to be square. That means that they're the same width. That means that their length and their widths are equal. So you can't have rectangular tiles, right? They have to be same. They have to be squares, right? So they have to be the same length and width. Okay. The wall design is to be 72 inches long and 42 inches wide, just like the picture indicates. Okay. All the square tiles must be the same size. So you can't use a 3x3 tile on one edge and then a 12x12 tile on the other edge, right? They have to be all the same size. And the length of the sides of the tiles must be a whole number. So you can't use a 6.25 inch tile, right? Okay. Then it says, using your knowledge of number theory and geometry, find 3 different sizes of square tiles that could be used to completely fill the rectangular space with no tiles overhanging the border. Okay? So just to understand that, I mean, it's like if we just guessed and said, well, I'm going to use a 5x5 tile, right? And you try to fill in, let's just say this column over here with 5x5 tiles. Then you're going to have 5 inches, and then 5 inches, and then 5 inches. You could lay 8 of those tiles. That would get you to 40 inches, but you need to completely fill this 42-inch gap. And so you need 1 more tile. But if you put 1 more tile, then that gets you all the way to 45 inches, which is too far, right? So if you lay 8 tiles, that's only 40 inches. If you lay 9 tiles, that's 45 inches. But you need 42 inches exactly. So obviously 5-inch tiles are not going to work, right? That's not going to be a number. What you need then is some tile that is a factor of 42, right? You need because you need that number of tiles, or you need that length to go into 42 evenly, right? So that you can lay that number of tiles along this row. So for example, just off the top of my head, well, I know that a 1-inch tile would work, of course, right? Because if I had 1-inch tiles, I could just lay 42 of them, and that would completely fill in this first column. Another tile that I could use would be a 2-inch tile, because 2 goes into 42, right? They're both even numbers. So 2 goes into 42. So I could lay, what would it be, 21? So I could lay 21 2-inch tiles, and that would completely fill in this space without any overhang on the edge. But now we have this other condition too, right? Because we also need that number of tiles to fill in this this width right here evenly. So for example, a tile that would work to fill up this length would be a 7-inch tile, right? Because 7 goes into 42, right? 42 is just 7 times 6. So I could lay 6 7-inch tiles, and that would completely fill in this space. But notice that 7 doesn't go into 72. And since it's a square tile, if it's 7 inches on one side, then it's 7 inches on the other side. And since 7 doesn't go into 72, that means that it's not going to fill in the entire rectangle evenly. You're going to have some overhang over on this edge. So a 7-inch tile won't work. So what do we learn, right? We learn that we need the size of the tile to be a factor of 42, but we also need it to be a factor of 72. So what we're really looking for here are common factors of 42 and 72. Okay, so we're looking for common factors of 42 and 72. So one way to get those would be to make a factor tree. You just think of two numbers that multiply to be 42, and there are lots of different options, but I'm going to say 6 times 7. And then you try to break these numbers down further. 7 doesn't go down any further. I mean, you could break it up into 7 times 1, but that's kind of pointless, right? 6 you can break down to 2 times 3. And so 42 is 2 times 3 times 7, right? That's the complete factorization of 42. And then we can do the same thing with 72, right? I think of 72 as 8 times 9. And I think of 8 as 2 times 2 times 2. And I think of 9 as 3 times 3. So 72 is 2 times 2 times 2 times 3 times 3. So that means, notice that 2 is a common factor of 42 and 72. 3 is a common factor of 42 and 72. But also 6, right? Because here we have a 2 times 3, which makes 6. And here we could do a 2 times 3, which equals 6. So 6 is also a common factor of 42 and 72. And I think that's it, right? Once you throw 7 into the mix, then you run into problems because 7 is not a factor of 72. So any multiple of 7 is not going to be a factor of 72. So you can kind of forget that. So I think those are our three options, 2, 3, and 6. And of course 1, which we've already mentioned. So tiles that will do the job, right? Tiles that will do the trick would be 1 by 1 inch tiles, 2 by 2, 3 by 3, and 6 by 6. Those are the 4 possible tile sizes that you could use to fill up that space. Okay, so that answers that first question. And in fact, we were only supposed to find 3, and we found 4. So I think we earn a double gold star with a rainbow around it or something. Okay. The second question says, determine the smallest number of square tiles that could be used to fill the rectangular space. Now, a common mistake students make with this second question is that they misread it. Okay. They go too fast, and they don't really think about what the thing is asking. They just see smallest. They see the word smallest, and they say, well, the smallest tile that will do the trick is a 1 by 1. But that's not what the question's asking, right? It's saying determine the smallest number of square tiles, not the smallest size of tiles. It's asking for the smallest number of tiles that could be used to fill the rectangular space. So what So the smallest number of tiles that could be used to fill up the space. Well, if you use a 1 by 1, a tile that's 1 inch by 1 inch, and it's got to fill in a 42 inch by 72 inch space, then you're going to have to use 42. Let me go back to the picture. You're going to have to use 42 tiles this way, 72 tiles this way, and of course you have to fill in all of the area in between, so it's going to be 42 times 72, right? So you'd have to use, if you used 1 inch tiles, then you would have to use 42 times 72 tiles to do the trick. How much is that? By the way, you can use calculators in this class. I'm okay with you using calculators. 42 times 72 is 3,024. So it would take 3,024 1 by 1 inch tiles to fill in that rectangular space, right? So obviously, well, I mean, maybe it's not obvious. So maybe we move on to the 2 by 2 inch tiles. How many of those would we be using? Well, 42 divided by 2 is 21. 72 divided by 2 is 36, I think. Yeah, 36. So you would use 21 tiles this way and 36 tiles this way. So for the 2 by 2 tiles, you would use 21 times 36 tiles. 21 times 36 is 756. Okay, so obviously, as the tiles get bigger, the number of tiles that you need in order to fill the space gets smaller. And that's what you're asked to find. You're asked, what's the smallest number of tiles that could be used to fill up the space? Right? So you're not asked for the smallest tile size that'll work. You're asked for the smallest number of tiles that'll fill the space. So obviously, if this number is decreasing as the size increases, then the smallest number of tiles is going to be however many tiles you use when you're using the 6 inch by 6 inch tiles. So a 6 inch by 6 inch, well, for the 42 inches, you would use 7 of those tiles. And for the 72 inches, how many would you need? You would need 72 divided by 6 is 12. Right? So you would use 7 times 12 tiles, so 84. So that's the smallest, this is the smallest number of tiles that you would need to use in order to fill up the space. So this is the smallest number. Now, let me go back to the problem, though, real quick, because this is something that I was thinking about as I was looking at this problem. Because as I look at this, it's a little bit ambiguous. So I'm assuming that the black and the white spaces are all tiles. Like these are black and white tiles. So I'm counting all of the white spaces as tiles. But if you don't consider the white spaces to be tiles, right? Maybe this is just blank wall. Right? They're trying to do this rectangular wall design. So maybe the black spaces are the tiles and the white spaces are just the wall behind the tile. In which case, you don't actually have 84 tiles here. You'd have something less than that. That becomes a much a little bit more difficult problem to try to figure out. And in fact, if that's the case, then I don't think that the 42 inch I don't think that the 6 by 6 inch tiles would work. Or would they? It depends, I guess. You can make it work. I was just thinking, like, if you wanted to end on black up here, then you would actually need an odd number of tiles. So actually 6 by 6 would work because you would be using 7 tiles. But it wouldn't work along this direction because that would be, you would use 12 of the 6 by 6. The 1 by 1s are even worse. The 2 by 2s are worse. So yeah, so I think this problem is impossible if you don't consider the white spaces to be tiles. Unless you're okay with ending on a white space instead of a black space up here. So So your individual interpretation could kind of skew the results of this particular question. And to maybe calm some of your anxiety about that, as long as your answer is well reasoned, you get full credit in my book. So, well, let me rephrase that. If you're ending up with an incorrect solution, right, then you're not going to get full credit. But what I mean is, if I had given you this problem on a test or a quiz, and you had interpreted the white spaces as just the wall behind the tiles and not as tiles themselves, but if it was clear in your work that that's how you were thinking about the problem, then if your work is correct, I would still give you full credit for it. Anyway, so I think that's all I have to say about the tile problem. Let me know if you thought of a different way to solve it other than doing this. And by a different way, I don't mean like I knew that I needed I knew that I needed common factors, but I just didn't use this factor tree idea. Like that's not what I mean. I mean, like, if you thought of a completely different way to do it, like with pictures or by working backwards or something like that, then let me know, and I can share those results potentially with the rest of the class. But that's that. So I think these are the different sizes of tile that will work, and this is the smallest number of tiles that you would need, right? 84. So that's all I have to say about that.